All right, today we're looking at 9.8 systems of linear and quadratic equations. Excuse me. You can solve systems of linear and quadratic equations graphically and algebraically. We're going to look at both of those today. So there's going to be multiple ways for you to look at this. You can figure out which one makes the most sense to you. This type of system can have two solutions, as you can see in the graph on the left. The two graphs, the linear graph and the quadratic graph, they intersect at 2 points. So they have two solutions. You can see that there could also be one solution in the second graph where the vertex is on the linear graph. And then you can see in the third graph that there are no solutions because the graphs never intersect. So when we're looking at number one, it says solve each system by graphing. So we can start with the y equals x plus 2. And we can do this by writing down what the slope is and what the y-intercept is. Okay? The slope is the number in front of x. So in this case, the slope is 1. And if we wanted to do it as rise over run, it would be 1 over 1. Okay? The y-intercept is 2. So we'll go to the y-intercept at 2. We'll go up 1 and over 1. And that will give us our 2 points that we need to draw our line. Okay, there you go. Now, with the y equals x squared plus 2, you can do a couple different things. Okay, I'm going to write this down here. You can do the traditional way, which is you just write down some x's and y's, and you get some points. So if we plug in negative 2 squared is 4. 4 plus 2 is 6. If we plug in negative 1 squared is 1, plus 2 is 3. If we plug in 0, we get 2. If we plug in 1, we get 3. And we plug in 2, we get 6. Okay, that's one way we can do this. And what we could do is we could plot those points and then make the parabola. Okay, but I also want to show you the way using transformations because we've done that in the past. Remember that our parent function for y equals x squared looks like this. Parent function would be y equals x squared, right? So it looks like this. Okay. I'm doing it in dashed lines because remember, it's just the parent function. It's not the actual graph. So let's see if you remember this. In the x squared plus 2, remember, we're looking for transformation. So that's if it's grouped, it's horizontal and opposite. If it's not grouped, it's vertical. So is this 2 grouped or not grouped? It's not grouped, right? Because it's not with the x being squared. So since it's not grouped, that would be a vertical translation 2 units up. So what that means is I'm going to take all of these points and I'm going to move them 2 units up. So that would be here, 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 there, and there. And then these, of course, would go off the screen. So what we have is this is our graph. Now, I also want you to notice that if you're somebody who would rather do it using the x and y table like we have below, if you look, negative 2, 6 is that green point right here. That's negative 2, 6. Negative 1, 3 is right here. 0, 2 is right here. 1, 3, and 1, 6, or 2, 6, I'm sorry. Okay. So there we go. Now, once we have the graph, we're looking to see where the two graphs intersect. We can see where they intersect, okay? They intersect at, our solution is at 0, 2, and at 1, 3. Those are our solutions because that's where they intersect. Okay, that's right here and here. You can see that's where the lines meet. Okay, all right, let's try this next one. We'll do the same thing, but we're going to do the transformation method only because you guys are familiar with the XY table. So I just want you to get used to this. So again, let's do the linear graph first. The slope is what? It's 1 again. So I'm going to put rise over run. So 1 over 1. And the y-intercept is -3. Okay, so 1, 2, 3. There it is. We're going to go up 1, over 1 to get our second point, which is right there. And then we are going to draw our line. Looks good. Then I'm going to plot my parent function. Remember, y equals x squared is the parent function. Okay, so that's 0, 0. Like if you plug in 0 for x squared, you get 0. If you plug in 1, you get 1. If you plug in 2, you get 4. You plug in 3, you get 9. And then remember that they have to be symmetrical. Okay. Good. So now we've got y equals x squared minus 5. Is the minus 5 grouped or not grouped? It's not grouped. The only way it could be grouped is if it was with the x inside of a parentheses with the square on the outside. So it's not grouped. So since it's not grouped, that makes it a vertical translation 5 units down. So we're going to take all the points from our parent function and just move them 5 units down. So we've got 1, 2, 3, 4, 5 right here. 1, 2, 3, 4, 5. Of course, that means it'll be here also, which is helpful. 1, 2, 3, 4, 5 right there, which means it's also right here. 1, 2, 3, 4, 5, and 5. So now when we actually graph this, whoa, that got a little bit weird. Let me fix that. Okay, we can see where they intersect. They intersect at, well, let me just mark them first. They intersect here and they intersect here. So that would be at -1, -4, and 2, -1, it looks like. Now, again, if you wanted to check your answers, what you could do is you could take these points and you plug them in and make sure that they both work. For example, if I plug in -1 to the top, -1 squared is 1, and 1 minus 5 is -4. That's exactly what we said the answer is, -1, -4. If I plug it into the linear equation, -1 minus 3 is -4. So you can see that that point works for both of them. So you can always plug them back in at the end to just double check. Okay, that's graphing. Now, we can also solve each system using elimination. Okay, so what I would do if I was going to do elimination is I would rewrite everything and I would include all the missing parts as placeholders, right? So y equals x squared has no x's and has no constant. The next one has no x squareds, has an x, and has a 2, okay? So we need to get rid of one of the variables. And the easiest one always in these kind of problems is to get rid of the y. To do that, I'm just going to run a -1 through the bottom here. Okay, so what's going to happen is I've got my y equals x squared plus 0x plus 0. And then I end up with negative y equals 0x squared minus x minus 2. And now I can add them together. Okay, y minus y is 0. X squared plus 0x squared is just x squared. Okay, 0x minus x is just minus x, and 0 minus 2 is just minus 2. Okay, so now you've got options. Okay, and your options are you can factor to solve, you can use the quadratic formula to solve, you can use completing the square to solve. Okay, so I'm going to do factoring, and then I'll just do the quadratic formula just so you can see that as well, since it's the most recent thing that we did. If I wanted to factor this, it would be x minus 2, x plus 1, which means that my solutions for x would be 2 and negative 1. Okay, but I can't leave that as my final answer because I have to figure out what y would be also, so I'd have to plug them both back in to get ordered pairs like we did with the graph answer. So let's say I plug in, I'll just do 2 since that's the one I have first. If I plug in 2, and I should be able to plug it into either of these equations and get the same thing. So 2 squared is 4, and 2 plus 2 is also 4. So one solution is 2, 4. When I plug in negative 1, negative 1 squared is 1, which is great. And if I go to the linear equation, negative 1 plus 2 is also 1. So just don't forget that you have to plug them back in to find the y's. We have to write our answers as ordered pairs. Okay. Now, if you did not want to do it using factoring, I'm going to rewrite this equation, x squared minus x minus 2 equals 0. You could have done it using the quadratic formula. So a is 1, b is negative 1, and c is negative 2, right? So you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that equals 1 plus or minus the square root of 1 plus 8, which is 9, over 2. So x equals 1 plus or minus 3 over 2, which equals 1 minus 3 is negative 2. Negative 2 divided by 2 is negative 1. 1 plus 3 is 4, and 4 divided by 2 is 2. And then you can see it's the same thing that we got up above, and then we have to plug them in to find the y's. Okay, plug them into the original problems. So either way works. All right, let's try it one more time. On the top one, we're not missing anything, so that's good. We've got y equals x squared minus 2x plus 2. On the second one, we have 0x squared plus 2x minus 2. Okay. On this problem, if we wanted to, we could just add them the way they are, but it would still be a little bit complicated. So I think we should always probably do the same method, which is run a negative 1 through, and that will give us y equals x squared minus 2x plus 2. That's the top equation. The bottom one becomes negative y equals 0x squared minus 2x plus 2. And then we can add them together. So remember, the whole purpose of running the negative through is so that we can cancel out the y's. So that becomes 0 equals x squared minus 4x plus 4. And again, if you wanted to, and you like factoring, you get x minus 2 times x minus 2. So x would equal 2, which means there's only one solution. Okay, but remember, we have to figure out what the complete solution is. So we have to plug in 2 for x. When you plug in 2 for x, it doesn't matter which one you plug it in. If I plug it into the top, 2 squared is 4. Negative 2 times 2 is negative 4. So 4 minus 4 is 0, and 0 plus 2 is 2. Okay, let's try the bottom one. 2 times 2 is 4, and 4 minus 2 is 2. Works for both of them. Okay. And again, if you wanted to, you could follow the steps and do the quadratic formula if you don't like factoring, which I recommend if you like to do the same pattern over and over again. You can remember, you can always use the quadratic formula to solve for quadratic equations. You can't always factor. Okay. All right. Since we just did a unit on quadratic formula, I won't show the example again. You can follow the example in example 1 if you would like. Okay, now word problem. So you can see some realistic problem here, or an actual problem. The populations of 2 different cities are modeled by the equations shown below. The population in thousands is represented by, I think it says Y, I can't see. And the number of years since 1907 is represented by X. Yeah, that's right. What years did the cities have the same population? What was the population of both cities during the years of equal population? So we're trying to do the same thing that we were just doing. Okay, it's just a word problem. So we're going to work it out the exact same way, right? And whatever we get for X is going to tell us the number of years since 1970. Okay. And then Y is going to tell us the actual population. So let's go ahead and solve this very similar to how we've done it before. You've got your Y equals x squared minus 22x plus 350. Then we've got Y equals 0x squared plus 55x minus 950. We're going to cancel out the Y, so I'll just run a negative through here. And by the way, it doesn't matter which one you run the negative through. I just like my x squared to be positive, so I always choose the bottom one. Or the linear one, I guess I should say. So you have Y equals x squared minus 22x plus 350. That's supposed to be an arrow. Oh, what happened there? This becomes negative Y equals 0x squared minus 55x plus 950. And we add them together. And of course, the Y's are going to go away. You're left with x squared minus 77x plus 1300. Okay. X squared minus 77x plus 1300. Okay, now for this one, let's go ahead and use the quadratic formula. A is 1, B is negative 77, and C is 1300. Okay, so we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's x equals 77 plus or minus, and then we'll use the calculator. I'll show it to you in steps on the video here, but I probably won't write them all in the notes, so you'll have to write those in. So we've got negative 77 squared minus 4 times 1 times 1300. Okay, 729. I changed my mind. I'm going to write it out over 2. Now what we'll do is we have to figure out what the square root of 729 is. So we'll square root this whole thing. It's 27. So we get 77 plus or minus 27 over 2. Okay, so x is going to equal, we're going to do 77 minus 27, which is 50, and 50 divided by 2 is 25. 77 plus 27 is going to be 104, and 104 divided by 2 is 52. Right? You could use the calculator if you wanted to, right? You could just, if you're not comfortable with it. Okay? All right, now this is where we have to really pay attention to what the word problem says, okay? So if you look very carefully, let me move this for now. I'll bring the calculator back in a second. If you look here, it says this. It says the number of years since 1970 is represented by X. Okay, so X represents the number of years since 1970. So we're going to have to make sure that we're paying attention to that when we're answering the question. Okay. All right. Now, it also says that the population are modeled by the equation below in thousands too. So we'll have to pay attention to that. But we'll let's solve and write things as ordered pairs, and then we'll go back and we'll fix them according to the question. Okay. So let's start with 25. We're going to plug that in. So I'm going to let you see this using the calculator, and I'm going to show you using both equations. Okay, so you've got 25 squared minus 22 times 25, and then plus 350. Okay, we get 425. Okay, now let's use the other equation. You've got 55 times 25 minus 950. I did it wrong because it says 55 instead of, let's do this again. You've got 55 times 25. Let's see if that works this time. There we go. And we still get 425. Perfect. So we know that that is correct because we tried it in both equations and we got the same answers. All right, let's do the same thing for 52. Okay, since we're already on this one, I'll do the linear one first. All I have to do is replace the 25 with the 52. I get 1910. All right, let's try the other equation. We have 52 squared minus 22 times 52 plus 350. 1910. Perfect, which means that we did it correct. Okay, now the trick is we have to actually answer the question being asked. Okay, so mathematically we've got a solution here, but we have to answer the question being asked. So let's do that. It says, what year or years did the cities have the same population? Okay, so let's do that first. In the highlighted section, you can see it says the number of years since 1970, right? So if we're answering this, the years the cities had the same population, we have to take the X values down below and we have to add them to 1970, right? So for this one, we would say 1995, and 52 years from 1970 would be 2. That's not right. Right, where's my problem at? 1970. It should be 52 years from that, 30 and 22. That's right, 2022. I guess we're predicting the future. Okay. All right. So those are the years the cities had the same population. Then it says, what would the population be? Now, this is another part where we have to make sure that we're looking. This says that the population in thousands is represented by Y. Okay. So we could just do it like this, 1995 oops, that's a highlighter, had 425,000 people. Okay, let me slide all these over so I can write people. We have to add the 3 zeros because remember it said it's in thousands. Okay, 2022, I guess we'll have, because that's not here yet, 1910000. That's a big city. Okay, 1,910,000 people. Okay, because it's in thousand, you could put a K, I guess, at the end instead of the 3 zeros. But I think we need to make sure that we're answering the question correctly too. So the population in thousands is represented by. So, and it's really difficult. Some of these word problems are tough to read too, because some might think, well, it's already in thousands, so we don't need to add the 3 zeros. I could almost see where you could read that in here based on the way it's worded. But to say that the population is in thousands and then you put 425 people, that doesn't really make sense to me. So I just went with my logical assumption on that. I'll try to make the questions more clear for you all on quizzes and tests. Okay, next, solve each system by substitution. Okay, so now we've done elimination. That's what we were doing above. Now we're going to do substitution. Okay, so for this, you've got y equals x squared plus x minus 60. So since that's what y equals, I can take this and plug it in for y here. So that would be substitution because I'm substituting it in. So I would get x squared plus x minus 60, which is what y equals, right? Equals 2x minus 4. Okay, some people like substitution a lot better, by the way, so you may be one of them. I'm going to subtract 2x over here. X squared minus x minus 60 equals negative 4. And then I'm going to add 4. Okay, now, one of these examples I will use factoring. So this one I'll use factoring. And then the other example, number 2, I'll use the quadratic formula. But remember, you can always use the quadratic formula. This is just to give you some variety for you to see. So here I can factor this to be, well, hold on a second. I'm going to do it this way. X plus 7, x minus 8. Okay, so x would equal negative 7 and 8. Okay, we have to plug them in to find the actual solution, right? The xy solution. So I'm going to plug in negative 7 first. Remember, it should work for both. I'll plug it into the linear one first because it's easier mental math. 2 times negative 7 is negative 14, and negative 14 minus 4 is negative 18. Remember, you guys do have calculators. I'm not testing you on your ability to calculate. So even for the quadratic, if you wanted to, you could just substitute it in. Right, so all I did is replace x with negative 7, and you can still see I get negative 18. Okay, I'll plug in 8. When I plug in 8 to the linear, I get 16 minus 4, which is 12. Okay, and so here I can take the negative 7 and plug in 8. And I still get 12. So I just confirmed that my answers have to be correct. Okay? All right, let's try one more time. We're going to take this and we are going to plug it in for y. So we get, let me move this out of the way so you can see it a little bit bigger. We get x squared minus 2x minus 5, which is what y equals, right? equals x minus 5. Okay, we got to move everything to one side, set it equal to 0. Subtract x. X squared minus 3x minus 5 equals negative 5. And then we're going to add 5. Okay, this one would be really, really simple to factor, but I told you that I would do the quadratic formula, so I will. You got a equals 1, b equals negative 3. What does c equal? C is 0, right? Because we don't have a constant. Okay, so you get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's going to equal 3 plus or minus the square root of 9 over 2. Okay, so x equals 3 plus or minus 3 over 2, right? 3 minus 3 is 0, and 0 divided by anything is 0. 3 plus 3 is 6, and 6 divided by 2 is 3. So now we have to figure out our ordered pairs to figure out what y is. So if we plug in 0 to the top, anything with an x goes away. We're left with negative 5. We do the same thing for the linear. You plug in 0 for x, you still get negative 5. Perfect. We just proved that we're correct there. We'll plug in 3. 3 squared is 9. Negative 2 times 3 is negative 6. So 9 minus 6 is 3. And 3 minus 5 is negative 2. If we plug in 3 to the linear, 3 minus 5 is negative 2. So not only did we solve it, we also know for a fact that we're correct because we plugged it back in to check. Okay, that is 9.8. Systems of linear and quadratic equations. You've learned multiple methods on how to solve this. You've got graphing, you've got elimination, and you've got substitution. So you'll get some practice on all of those and see which one makes the most sense to you. And hopefully this was helpful. And like always, if you have any questions, I will be happy to answer them.